let's imagine that we work in a laboratory and we are given a task, and our task is to figure out what mass of ammonia we can make if we use 1,221 grams of hydrogen and excess nitrogen, which just means that we have as much nitrogen as we could possibly need, probably from the air around us. So let's take a look at how to approach this problem. First, again, we should start with what the problem gave us. So let's start with 1,221 grams of hydrogen. Make sure that you put not only the unit, but the chemical symbol on each of these numbers. It'll make it easier to understand what's going on. Now we know that when we do stoichiometry, we use mole ratios. But we have to get moles first so that we can then use that mole ratio. So your first step is converting grams to moles. What I'm going to do is convert these grams of hydrogen into moles. And I know that for every 1 mole of hydrogen, which is H2, I have 2 grams of hydrogen. So it turns out that I'm dealing with 610.5 moles of hydrogen. So that's my first step. Convert the grams of what I was given into moles. Now I can use the mole ratio, and I can use this 610.5 moles of hydrogen to figure out, using the mole ratio, how many moles of ammonia I could make. Now the mole ratio that I'm interested in is what I want, which is 2 moles of ammonia for every 3 moles of hydrogen, which is what I had. In this second step, the coefficients from the balanced equation should be used as that mole ratio. So I put what I want, 2 moles of NH3, over what I had, which is 3 moles of H2. Okay, make sure that the correct units are there. If so, they will cross out and you will be left with moles of what you're interested in, which is NH3. My answer to this step should work out to be 407 moles of ammonia. Now my final step is to take those moles of ammonia and convert them into grams. And I can use my periodic table to add up the molar mass of ammonia. When you add up 1 nitrogen and 3 hydrogens, you get 17 grams of NH3 for every 1 mole of NH3. I multiply my moles by the molar mass of ammonia. Make sure that my units cross out, moles of ammonia, I'm left with grams of ammonia, and my final answer is 6,919 grams of ammonia. You see that I wrote the unit, I wrote that it's ammonia, and I also wrote myself a note that this is how much ammonia can form. It's a good idea to remind yourself of what you're trying to accomplish. We were trying to figure out how many moles of ammonia and how many grams of ammonia can form, and that's what we've done. So in summary, the steps for solving a mass-to-mass problem would be step 1, convert grams to moles. Step 2, convert moles to moles. And to do that, you're going to use the coefficients from the balanced equation. And then your final step is to convert the moles back into grams. There are sample problems in your book in Chapter 9, Section 1 that you could work on if you wanted more practice.